Lesson 5.1, Writing Linear Equations from Situations and Graphs. Lesson 5.1, Writing Linear Equations from Situations and Graphs. Writing an equation from a graph. You can use information presented in a graph to write an equation in slope-intercept form. Okay, the video from this lesson will help us understand example 1.
Now, we can actually consider this process the other way. Suppose that someone gives us the graph of a line, we can actually write the equation of the line, and we can use the familiar equation we know, which is the slope-intercept form. So remember, the slope-intercept form is y equals mx plus b, where the m is a number that represents the slope, and the b is the number that represents the y-intercept. So if we think about it this way, if I take a look at this line, for example, can I actually find the equation of this particular line? Well, the answer is yes, of course, we can do anything. So where do I start? The first place I start is I want to locate the y-intercept. So the y-intercept is this b, which is where it crosses the y-axis. And where is that? Well, it's way up here. Let me use red here. That's this point right here. So what is that? Well, we have to count. 1, 2, 3, 4, 5, 6. So I see that b equals 6. So b equals 6. That's the y-intercept. Point right here. Now, how are we going to find the slope? Well, the thing to do is to kind of look through this picture and see if we can see where this line actually cuts through right at the crosshairs of our grid. Like, it doesn't quite do it there. It's hard to read that y value, hard to read the y value here. But look at that. That's a direct hit right here. And I can actually read the value of that point. What's the coordinates of that point? Well, it's 1, 2, 3 units over, and 1, 2, 3, 4 units up. So this is the point 3, 4. And now, using this point and this point, I can ask, okay, how do I find the slope? Well, it's going to be rise over run. Now, notice that this line actually is pitched down. As the x's get larger and larger and larger, the line is falling. That tells me this slope is going to be a negative number. So it's going to be negative, and so how do we do this? Well, if I start here, what do I have to do? Notice I have to go down. That's negative. Down how far? 1, 2. I have to go down 2, so that means that my numerator on the slope is going to be 2, and then I'm going to go over 1, 2, 3. So that means my denominator should be 3. And notice I'm going 3 in the positive direction, but I'm going down 2, so my slope is going to be negative 2, that's my change in the y, drop 2, and go over 3. And so my slope is negative 2/3. You see how I got a numeric value to the pitch of this line? I actually found its slope. Well, now it's a piece of cake, right? Or a piece of tofu, because we should be a little bit more healthier. Yeah. Then y equals the slope, which we see as negative 2/3 x, and then plus the y-intercept, which is 6. And so that actually is a really cool, fancy-looking equation whose graph is actually depicted by this picture. Isn't that cool? There's a connection between equations of lines and graphs of lines. And now we're seeing that together.
Okay, lesson tutorial, quick review. Writing an equation in slope-intercept form. Writing an equation in slope-intercept form. Write the equation of the line in slope-intercept form. Here to give us our line. All right, and like he said, the first thing we want to find is our y-intercept. And remember, this equation is very important. Y equals mx plus b. We want to find the b first because it's easy to do in the graph. We go right here, we're at 0. And our b value is going to be 1, 2, 3, 4, 5, 6. So our y-intercept is 6. And 6 occurs, the y-intercept occurs when x is 0. So far we know the y-intercept at 6. Now we're going to find another point, and we're going to find the next point by counting our slope. So we're going to count the slope, and when we count the slope, we want to locate another point that is directly on the crosshairs. Directly on the crosshairs. See, this would be a good point to pick, and there would be a bad point. Bad point. Right here would be a good point you can use if you wanted to. Bad point. Bad point. Right here on the x-axis, that would be a good point to use. All right. Or you can use this point right here. It's directly on the crosshairs. All right, but anyway, we're going to count our slope. So we're going from here to here. So when I'm counting the slope, I'm going to go 1, 2, down. That's my rise. That's a -2. Then I go 1, 2, 3. I'm going to the right for my run. That's my x. So my slope then is going to be a -2 over 3. A -2 over 3. Now notice how they have it written. M, slope, is equal to rise over run, which is equal to a -2 over 3. Don't forget that -2 over 3 can be rewritten in 2 additional ways. It could be written where we just found it. That is, we said a -2 over 3, but notice how it's written there with the negative sign right in the middle, right? Or it can be written as 3. Excuse me, that's incorrect. It could be written as a +2 over a -3. Now, how does that situation come about? That comes about if we were to go the other way. Let's say we count it going up instead of going down. If we count it going up, we get 1, 2. See how the run is a +2 because we're going up. And our run would be 1, 2, 3. That would be a -3 because we're going in the negative direction for the run. Once again, going up, 1, 2. So my rise is 2, a +2. And my run would be 1, 2, 3, negative. See that? But now here's what you notice. What is a negative divided by a positive? That's going to be a negative. What is a positive divided by a negative? That's going to be a negative. So both situations gives me the same answer, but I have to know how to count my slope in both directions. All right, so now after we found the y-intercept at 6, we found the slope at a -2 over 3, we're going to use our equation, y is equal to mx plus b, to write in the equation of the line. So y is equal to, what was m? A -2/3. What was b? A +6. So there's our answer. Okay, now for example 2, we're going to be writing an equation from a description. Example 2, writing an equation from a description. You can use information from a description of a linear relationship to find the slope and y-intercept and to write an equation.
All right, let's take a look at a quick application. So to rent a tuxedo, a formal wear store charges $50 plus $40 per day. The total cost as a function of the number of days is shown in the graph. So check out this graph and you can see this represents the total cost as a function of the number of days rented. The first thing we're asked to do is write an equation that represents the total cost as a function of the number of days. Okay, that's the first thing we have to do. Then we have to identify the slope and the y-intercept and describe their meanings. We can do that. And finally, suppose that you actually want to rent the tuxedo for 3 days. Let's figure out what the cost of that would be. All right, so first of all, how would you find the equation of this? Well, you can do it in a variety of ways. You can sort of read through the question again, and that actually has within it the equation. Because the amount that it costs, which is y, is going to be, well, how many days you've rented it multiplied by 50. So it's 50 times x. Oh, wait, the number, oh, no, I'm sorry, 50 is 40 times x, 40 times x, 40 times x, 40 times x, because it's $40 per day, per x. You have more x's, then you have more 40s. So we have 40 times x, and then plus that one-time charge of $50. Okay, so the equation is y equals 40x plus 50. So you can get that from there, or notice that you can also get that by looking at the graph. Let's just see this for a second. Notice that the y-intercept is at 50, which is right here, and then what happens if you go over up to here? What's that change? That change is 40. right? Because 1, 2, 3, 4, and that's 1 day. So 40 over 1, that's 40. So anyway, that's the first thing. Write an equation. So there's the equation. Identify the slope and the y-intercept. So the slope, we just did that. The slope is 40, and we just saw that. Rise over run, 40. And the y-intercept is 50. It crosses the y-axis at 50. So that's great. And then finally, describe their meanings. Well, what's the meanings? Well, the y-intercept tells us how much we're going to pay for the tuxedo if we rent it for 0 days. So it means if we rent it for 0 days, it just costs us that initial $50. And what about the slope? Well, the slope represents the rate of change of the cost per day, right? Every extra day involves an additional $40 cost, okay? And then find the cost of the tuxedo if it is rented for 3 days. Well, we can do it in a variety of ways. We can just go to the picture and say 3 days seems to hit right here, which seems to be $170. So my guess is 170. But we can confirm that by putting in x equals 3 into here and getting the exact value. And we see 120 plus 50, look at that, that equals 170, just as we had predicted. So it's sort of neat. The great thing is that if you have a line, you can actually write it in slope-intercept form. And the nice thing is, whether you're renting a tuxedo or whether you're just getting ready to go out a night on the town, a little bit more casual, the slope-intercept form is the tuxedo. It's the black tie of the line. I'll see you soon.
Okay, the main thing in this lesson tutorial is you have to know how to write the equation both from the problem and from the given graph. Okay, from the problem, it says to rent a tuxedo, a formal wear store charges $50 plus $40 per day. $50 plus $40 per day. So $50, that's your initial charge, and $40 per day, that's going to be your slope. So y is equal to m, which is 40, that's your slope, times x, the number of days, plus 50. That's your b, that's your y-intercept. That's your initial charge. So the actual equation then is y is equal to 40 times x plus 50. Okay, now, to make the same equation from the graph, you would notice first your y-intercept is located right here. And the y-intercept right there is going to be 50. Between 40 and 60 is going to be 50. Also, you notice in they're counting by 10. 0, 10, 20, 30, 40, 50, 60, 70, and so on. All right, so then your y-intercept from the graph is indeed 50. Okay. Next, you're going to try to find your slope. So to find the slope, that means you got to find another point on this graph. And you want to find a point where the crosshairs are pretty much perfect. So a point for that would be right here, right? Nowhere on here other than there does the crosshairs meet. They meet there and they meet there. But we'll start right here because this is very close to this one, to that point right there. Okay, now after locating that point at the crosshairs, now I can count my slope. So let's go. 10, 20, 30, 40, 50, 60, 70, 80. So my rise was 80. So my rise at this point is 80. That's my y. Now my run, to get to the x, my run is going to be 1, 2. Once again, my run is 1, 2. So I have rise of 80, run of 2. 80 divided by 2 is 40. So my slope then is 40. So far I have y is equal to 40 times x plus 50. Same as I got from the original equation. Okay, and the last thing they wanted me to do is to figure out the cost for 3 days. So I go to x, there's 3 days, go up on the line, and I'm at $170. The same thing with the equation. In place of x, I'll put 3. 40 times 3 is 120. 120 plus that 50 is 170.